Beautiful spring afternoon out here in the urban food forest. Bananas. Got a pomegranate there, our fig, and a lovely avocado tree, and of course the girls doing their part. So this house has a Greywater system installed, which I think if you tried, it would be hard to install or hard to design something that was worse for the user and or efficient. So let me show you what I mean. Here's the hatch. About a 4 by 4 foot hatch, and then a pit which has been dug out below grade, and a tank has been installed to capture gray water from the house and then pump it out to the yard. So see if I can zoom back out here. So we've got, this is the input here, and there's two valves. There's one that leads out to the sewer, and then there's one down here, which is currently shut off, that leads into the input into the gray water tank. So when this is running properly and you've got the valves set, you would have this set to off, this is sewer. You would have that set to open, and then gray water would go enter into the tank. And then when it reached a certain level of water, it would automatically be pumped out this into the yard. So this, I guess it looks like a 1-inch pipe, then underground goes into a 1/2-inch pipe, and then further out to irrigate the various plants. So lots of reasons, even if this was working properly, why this I think is a bad design. First of all, you've got two separate valves for the water. You got one there, which requires a good amount of flexibility and strength just to turn it on and off, and you've got this one. So theoretically, you could close them both off and then cause major problems inside as the water, gray water, would back up into the fixtures. So that's the first issue. So you would want to shut off the gray water input into and let it go to sewer if you were, for example, using caustic cleaners like bleach and that sort of thing. So that's the reason why they put the valves there, but it's just terribly not user friendly. You got to come outside, you got to lift up the hatch. Anyway, so that's reason number one why this is a terrible design. The next reason is that this outlet box, which powers the pump, is very close to the unit here. And what happened over time, you can kind of see it's rusty. Well, when the incident happened that caused the whole thing to malfunction, it sprayed water onto the outlet and shorted it out, and so, which further exacerbated the problem, because at some point the water had nowhere to go, and it more or less just kind of burst out, and it broke this pipe right here. So this setting. So really bad stuff. So I'm trying to fix it here and maybe make some improvements as we go. Okay, so the next issue is the gravel bed on which the tank was placed. I don't think it has the right degree of the size of the various chips. Like the manual says, you shouldn't put jagged, sharp chips at the top layer here. So maybe something more like sand. Anyway, so I don't think this was filled properly, and consequently the tank is not level and plumb. It sort of like lists this way a little bit. So when you can kind of still tell there's a little bit of water in the screw holes there, but this thing was full. I pumped it out with the sump pump, and it's just tilted this way. So that's probably causing some sort of issues. But what happened was more or less catastrophic failure when it filled up, and maybe because of it being uneven, the plastic probably malformed, and what it did was it caused this threading here to fail. So basically caused this to break, and then water shot out everywhere, which then shorted out the circuit. And it seems like it should just get it. You can get a different set of threaded piece here. I did that. It's simply not working. So that's my conclusion, that the whole cover, if not the whole tank, is like basically distorted, so that these threads will not seal. So we got that. What else? I think that was it. Yeah. So I was able to get a separate sump pump and pump out the water here mostly. So at least now I can remove the pump from the pit and take a closer look. But meanwhile, the cover, all of the bolts came out except this one and this one. They I don't know what the deal is, if there's a nut that's rusted, but it just just keeps turning and turning. So anyway, that's where we are now. But design wise, what I think what we can do if we do some repairs on this would be, first thing would be to add a 3-way valve on this pipe. So like a J&D, or I think there's another brand that makes a good 3-way valve. That way we could just easily switch from one mode to the other without having to turn this one off and this one on and hope you got the order correct and all that stuff. So I would say replace this piece here with the 3-way, and then you can take this and maybe cut it off here, add a clean out, and then sort of, once this whole thing back in place, sort of rotate the whole unit so that the 3-way, the piping that can go back down into the inlet, will be rotated over here and be more aligned with the 3-way. So that's, I think, the best that can be done with this system. It's never a best practice to even store gray water because it's a vector for pathogens, but in this case it worked for a few years and then didn't work. So that's kind of what we're working with here, and I'm not sure how we would solve this. I'm going to replace the outlet with another GFCI, possibly relocate the outlet. I'm not sure. So anyway, let me know if you have any ideas as to how you would design this, or if you would just scrap it and start over, or what you think, especially about the valve.